Hello friends, we are going to start the first topic, rotational dynamics. In this topic there are two parts. First is the circular motion and the second part is the rotational motion. First we are going to study about the circular motion. What is circular motion? Circular motion is the motion of the particle along the circumference of the circle. There are many examples of the circular motion. The electrons revolving around the nucleus, the planets revolving around the sun, these are the examples of the circular motion. We studied that circular motion is always an accelerated motion. Why it is an accelerated motion? When particle is in circular motion, the linear velocity of the particle is always changes according to its position. If the particle is initially at A, its linear velocity along this direction, which is the tangential to the circular path. If after some time it comes at point B, it is again changes according to the tangent to the circular path. Hence, in every case, at every moment, the direction of the particle, the direction of the linear velocity of the particle continuously changes, and hence we know that whenever there is a change in the linear velocity, then there is an acceleration. Hence circular motion is an accelerated motion. Now we are going to study about circular motion. There are some basic definitions which we have to know. First definition is the radius vector. Radius vector. Radius vector is the position vector of the particle drawn from the center of the circle. Radius vector, which is denoted by R bar, which is a vector quantity and it is directed outward from the center of the circle. The radius vector is a vector quantity, and as it is a distance, it is measured in the meter. Hence, the SI unit of the radius vector is meter. Next definition is angular displacement. Angular displacement is denoted by theta bar. Now, what is angular displacement? Angular displacement is the angle drawn by the radius vector in a small interval of time. Means initially, if consider a particle is in a circular motion, initially the particle is at point A, and if after a small interval of time it comes at point B in small interval time delta t, then the angle drawn by the radius vector in that small interval of time is called as the angular displacement. Means in this case the angular displacement is an angle. We studied in previous class the linear displacement. Linear displacement is a distance, means a particle moves from one point to another point. This is a distance. But in angular case, angular displacement is an angle. In linear case, it is a distance. The angular displacement, as it is an angle, it is measured in the SI unit radian. We know the SI unit for angle is radian. Hence, the SI unit for angular displacement is radian. Angular displacement is also a vector quantity. The direction of the angular displacement is calculated by the right hand rule. Right hand rule denotes, if the curled finger denotes the direction of the motion of the particle, then thumb denotes the direction of the angular displacement. Means consider an particle is in circular motion consider in an anticlockwise direction, then according to right hand rule, if the curled finger denotes the direction of the motion of the particle, then thumb denotes the direction of the angular displacement. Means in this case, the direction of the angular displacement is in the downward direction, which is perpendicular to the plane of the circular motion. If the particle is in circular motion in anticlockwise direction, then according to right hand rule, the direction of the angular displacement is along the direction of the thumb, means in this case it will be in the upward direction, which is perpendicular to the plane of the circular motion. Means as the direction of if the motion of the particle is clockwise direction, then it is in the downward direction, and if the motion of the particle is in anti-clockwise direction, then it will be in the upward direction. Next term, angular velocity. Angular velocity is denoted by omega bar. Angular velocity. Let's consider the terms in the linear motion and angular motion. In linear motion, displacement is s bar and the velocity is given by v bar is equal to ds bar by dt. Means the rate of change of displacement with respect to time is the velocity. Now we say the rate of change of linear displacement with respect to time is the linear velocity. In similar case, we can write the rate of change of angular displacement with respect to time is angular velocity. It is analogous to the linear velocity. Rate of change of linear velocity, linear displacement with respect to time is linear velocity. Similarly, the rate of change of angular displacement with respect to time is the angular velocity. The SI unit for will be radian per second. The relation between linear velocity and angular velocity can be given by v bar is equal to omega bar cross r bar. Means linear velocity is the product of angular velocity and the radius vector, cross product of the angular velocity and radius. This will be the relation. In magnitude, v is equal to r omega. This is the relation between the linear velocity and angular velocity. Now the direction of the angular velocity, we know that in linear velocity, the linear velocity has the direction of the linear displacement. Similarly, in this case, the linear angular velocity has the direction of angular displacement. Means if the particle is in anticlockwise motion, we know that according to right hand rule, the direction of the angular displacement is in the upward direction according to right hand rule. If the curled finger denotes the direction of the motion of the particle, then thumb denotes the direction of the motion of the angular displacement. Similarly, if the particle is in anticlockwise direction, the direction of the angular velocity also in the same direction. Both have angular displacement and angular velocity, both have the same direction. Now, next term, angular acceleration. Before we go into angular acceleration, first just revise the linear acceleration. Linear acceleration is a bar is the rate of change of linear velocity with respect to time. Similarly, here we can angular acceleration is denoted by alpha bar. The angular acceleration is denoted by the rate of change of angular velocity with respect to time. But angular acceleration when the particle is in circular motion, there are two types of acceleration. Consider a particle performing a circular motion. There are two types of accelerations. First acceleration is the change in the direction of the motion, linear velocity of the particle. That acceleration is called as radial acceleration, which is directed towards the center of the circle, and therefore it is called as radial acceleration. And another type of acceleration is tangential acceleration, which is denoted by AT, which is tangent to the circular path. The radial acceleration is due to the change in the linear velocity, and we know that at every moment there is a change in the linear velocity. Means at every moment of the particle, the linear velocity is in this direction. Means whenever there is a circular motion, there is a change in the linear velocity, and due to this there is a production of radial acceleration, and therefore particle, whenever particle is in circular motion, there will be the radial acceleration. But tangential acceleration is only produced when the particle is speeding up or slowing down. Means if the particle is not in uniform circular motion, then there will be the radial acceleration and tangential acceleration, both are present. But if the particle is in uniform circular motion, then there will be the only radial acceleration. There are two types of the circular motion. First is the uniform circular motion. Which is in short denoted by UCM, and another is non-uniform circular motion. First, uniform circular motion. Uniform circular motion means if the particle is in the circular motion, completes an circle in equal interval of time, then that circular motion is called as uniform circular motion. Means the particle moves with the constant speed or constant angular velocity in the uniform circular motion. Whenever particle is in the uniform circular motion, then same angular velocity omega. Therefore, there will be no tangential acceleration in this uniform circular motion. Therefore, when particle is in uniform circular motion, there will be only the radial acceleration present. The tangential acceleration will be 0 because there is a particle moves with a constant speed along the circumference of the circle. Second is the non-uniform circular motion. Non-uniform circular motion, if the particle moves with increasing speed or decreasing speed, means the particle is speeding up in the circular motion or slowing down. For example, if we switch on the fan, the particles at the tip of the fan has an increasing speed. Similarly, if we switch off the fan, the particles are slowing down. That is the example of non-uniform circular motion. When the particle is in non-uniform circular motion, due to the speeding up or slowing down, there will be the tangential acceleration and also the radial acceleration. Means in non-uniform circular motion, the total acceleration in the body will be due to the radial acceleration plus tangential acceleration in the vector form. Now, what is about the direction of the angular acceleration? Consider is an particle moving in anticlockwise direction. Then we know that the angular displacement can be given by the right hand rule. We know that the angular displacement will be in the upward direction. Similarly, the direction of the angular velocity will be in upward direction. Consider a particle is in non-uniform circular motion. Means if the particle is speeding up or slowing down, then the direction of the angular acceleration is given as, if the particle is speeding up, means its velocity is, angular velocity is in increasing, then the direction of the angular acceleration is same as the angular velocity. Means consider particle performing a circular motion in anticlockwise direction and it is speeding up. Then its direction will be same as the angular velocity. But if the particle is slowing down, then its direction will be in the opposite direction of the angular velocity. Means if the particle is slowing down, then the alpha bar has the direction against or exactly opposite to the angular velocity. Similarly, this is the example of if the particle is moving in the anticlockwise direction. What will if it is moving in the clockwise direction? In this case, according to right hand rule, the angular velocity has the downward direction. If this particle is speeding up, means its speed is increasing, then the omega bar and alpha bar has the same direction. Means in this case alpha bar is in the downward direction, and if it is slowing down, then the direction of the angular acceleration is opposite to the angular velocity. Means if this particle is slowing down, then its direction will be in the upward direction.